Let's talk about igneous rocks. Here are our learning goals for today. Know the three types of rocks: igneous, sedimentary, and metamorphic. Know how igneous rocks are formed. Know the difference between mafic and felsic. Explain the difference between intrusive and extrusive. Describe how igneous rocks are classified. And describe the following igneous intrusions: dike, sill, and pluton. Alright, so why are rocks important? Just like clues at a crime scene that allow detectives to determine what happened, rocks help geologists figure out how the earth formed the way it did and why we have mountains where we do and earthquakes where we do and things like that. Because if you study the rocks, you'll understand the environments in which the rocks formed, the conditions under which they were formed, and that allows you to piece together the history of the earth. That's how we know how the earth has changed over time. Now, what is a rock? Rocks are made of one or more minerals. I want you to think about this piece of fruitcake. This is like a rock. This fruitcake has pieces of different fruit in here. We could think of these as being minerals, right? All held together by a matrix, right? In the fruitcake's case, these are pieces of fruit held together by cake. If this was a rock, these would all be different minerals, and this might be calcite or quartz holding it all together. Now, rocks can be made just of one mineral, kind of like a peanut butter cookie is uniform throughout. Well, rocks can be made of just one mineral and be uniform throughout. There are three types of rocks. There's igneous rocks, metamorphic rocks, and sedimentary rocks. Today we're going to talk about igneous rocks, right? The Earth's crust is mostly igneous rock. Igneous rocks are formed from molten rock that cools off. Hot lava, basically, that cools off and solidifies. Now, we need to use those terms a little bit more specifically. Magma is liquid molten rock below the Earth's surface, and lava is liquid molten rock above the Earth's surface. So you can think of it as the same thing, we just give it a different name depending on where it's found. If it's in the Earth, it's magma. If it's on top of the Earth, it's lava. But it's all melted molten rock. Now there's two types of magma. One called felsic. It's kind of a funny name, but it's easy to say, felsic. It's rich in silica and low in iron, and it makes light colored rocks, like granite. Granite is full of minerals that are high in silica, low in iron. Some of the darker minerals here have more iron in them. But felsic magma makes felsic rocks, light-colored rocks. Mafic magma is just the opposite. It's rich in iron and low in silica, and it makes dark-colored rocks. This is basalt. We learned in oceanography that basalt makes up the ocean floors. Look how dark this rock is compared to the granite. This rock is made up of minerals that are high in iron and lower in silica than the minerals that make up granite. Now, these two types of magma will make a big difference when we talk about volcanoes. Felsic volcanoes are explosive when they erupt. Volcanoes that have mafic magma erupt relatively gently. Now, rocks that form below the ground from magma are called intrusive igneous rocks. Intrusive are inside the earth. So that's one easy way to remember it. Inside the earth, they're intrusive. And because they're inside the earth, then they're formed from magma. The other type of igneous rocks are rocks that form from lava, from magma that's escaped the earth and is now on the surface. Right? We call these extrusive rocks. and extrusive reminds me of exit. So these are formed from lava, which has exited the earth and is now on the surface. All right, so now we know a few basic characteristics of igneous rocks. We're going to learn how to classify igneous rocks, and we're going to do it two ways. We're going to do it based on their composition, the type of minerals that are in the rock. Are they felsic, high in silica, low in iron, or are they mafic, high in iron and low in silica? And also the size and texture, or the size and arrangement of their crystals, their texture. And that's going to depend on, did they form underneath the earth? Are they intrusive rocks? Did they form from magma? Are they extrusive rocks? Did they form on the surface of the earth from lava? Okay. Intrusive rocks, ones that formed inside the earth from magma, have larger crystals because magma takes a long time to cool off when it's inside the earth. And when we studied minerals, we learned that minerals will grow characteristic crystal shapes if they're given time and room. Well, intrusive rocks take a long time to cool off. That gives those crystals time to grow. They get pretty big. So intrusive rocks have large crystals. Extrusive rocks is just the opposite. Lava on the surface of the earth might cool off in a matter of months, weeks, days, sometimes minutes. Those crystals don't have time to grow large. So extrusive rocks, rocks that form from material that exited the earth, lava, these extrusive rocks cooled off quickly, so they have small crystals. Intrusive rocks, rocks that formed inside the earth from magma, cool off slowly, so they have large crystals. This is going to be really important. Now, if they have large crystals, we call them coarse-grained rocks. So coarse-grained rocks are going to be intrusive rocks that form from magma. Right? Here's a great example. This is granite. You don't need a magnifying glass to see these crystals. All these little dark spots are crystals, right? The lighter crystals are a little bit harder to see unless you see the rock up closely, but these are big crystals. You don't need a magnifying glass to see these, right? The other texture is fine-grained, small crystals. These are going to be the intrusive rocks, the ones that formed, these are going to be the extrusive rocks. These are going to be the ones that formed on the surface of the earth from lava. They're going to have cooled off quickly. Crystals won't have had much time to grow. They're going to be small. Here's a great example. This is rhyolite. This is made out of the same minerals as granite, but these minerals cooled off very quickly. They didn't have time to grow large crystals. They're very tiny crystals. You need a magnifying glass to see the crystals in this rock. Now, there's a few that you can see that are a little bit bigger. Some of these are bubbles. But the vast majority of these crystals, you got to have a magnifying glass to see. All right? Porphyritic is a mixture of the two. Let's say you had some magma that was cooling off under the surface of the earth. Crystals were growing, and then that magma erupted as lava and cooled off quickly. Then you could get a mixture. You could get some big crystals, some tiny little crystals, and some in between. So a porphyritic texture is a mixture of extrusive and intrusive. Right? Now, we also can get some odd textures. One is porous or foamy. This is pumice, right? Pumice is foamy or porous. Pumice forms when lava erupts from a volcano and it has a lot of gas in it. So the gas is trapped in bubbles. This looks kind of like a sponge, really, when you get up close to it. And it's very, very light. It can float on water. And the last texture we're going to talk about is glassy. That's no visible crystals at all. In fact, it's kind of like glass. It is glass. It's volcanic glass. and it breaks just like glass. It looks like glass. It's black, right? Uh, Ancient peoples used obsidian, volcanic glass for weapons, for cutting instruments, because this stuff is really sharp. So those are the textures that we're going to talk about. We've got coarse-grained, fine-grained, porphyritic, porous, and glassy, right? So coarse-grained cooled off slowly, right? If we have a felsic rock, then it's granite. If we have a mafic rock, then it's gabbro. Gabbro is a rock made up of dark minerals, high in iron, low in silica, but it has large crystals. And if we get a mixture of felsic and mafic magma, then we get something in between, an intermediate magma, and that forms this rock called diorite. Now, if you look at it, this is mostly light colored minerals. This is almost all dark colored minerals. This is about half and half. It's an easy way to remember it. Now, if we look at fine-grained that cooled quickly, these would be extrusive rocks, right? If we have felsic lava, one that's high in silica, low in iron, then we get a rock called rhyolite. If we have a mafic lava that's high in iron and low in silica, cools off quickly, then this is basalt. And halfway in between, we get andesite. Andesite is the major rock that makes up the Andes. That's where it gets its name. It's an extrusive rock that cooled off quickly. But it's a mixture of felsic and mafic minerals. Okay? Now there's also some things called igneous structures. Now think about it. Magma is rising up through the crust of the earth. Some of it's going to make it to the surface and erupt in a volcano. Some of it's not. And some of that magma is going to cool off and solidify into igneous rocks. It's going to kind of get stuck on its way up through the crust. And it forms these different structures. Plutons, dikes, and sills. We're not going to worry about laccoliths and batholiths too much. Let's look at some pictures. This is a dike. There was a crack in this lighter colored rock, and this dark magma squeezed its way in between these two rocks and formed a vertical structure. This is called a dike. Now, if you go out to the western United States, here in New Mexico, you'll see the neck of an extinct volcano. There used to be a large volcano in this area, and this was the magma inside it. The volcano eroded away. All we have left of the volcano is this magma. But look out here. There were cracks in the rocks, and magma forced its way up into these cracks and formed these fence-like vertical structures called dikes. These go on for miles. They're really easy to see. Another igneous structure is called a sill. A sill forms when there's a horizontal crack. So this is the Purcell Sill in Glacier National Park. This is a very distinctive feature that you'll notice in many places in the park. And there was a horizontal crack between layers of rock, and this magma forced its way in and solidified. Then the mountains were formed. These rocks that we're looking at here were raised up high in the air. Erosion removed some of the rocks, and now we get to see the sill. And when we talk about metamorphic rocks, we're going to look at this picture again, and we're going to notice how different color this rock is from this rock. And we'll tell the story of that when we get to igneous rocks. And the last igneous structure we're going to talk about are plutons. Plutons are just one big massive blob of magma that solidified underground and basically formed one big giant rock. This is one big giant rock right here. This formed deep underground. It used to be liquid magma, cooled off, solidified, formed this giant intrusive rock. And if you go out to Yosemite Valley, these beautiful cliffs and all these famous features in Yosemite Valley are plutons. This was liquid rock at one point in time deep under the earth. It solidified. The rock over that was on top of it was eroded away, and we're just left with the plutons. Next time, we'll talk about sedimentary rocks.